Hi.
Hello.
Okay, there you are. Let's see if it will even do the guest cam. It did. There's Fraser, and look, it kind of saved it. It kind of did it. So I'm not going to adjust anything.
Oh, really? You've got a setting saved for me?
Maybe. I mean, Dr. Paul could mess that all up, though.
It's same kind of general profile. I can't imagine it would look that different.
Okay, say hi to Fraser. If you need to know more about him, there's a huge, long list of commands because he's got a lot of stuff on the internet. The more you are an internet VIP, the longer that command gets, and you can't
Right,
truncate
right.
it.
The more things that you work on.
Right. So how are you doing?
What a week.
I know.
I am worn out. Not gonna lie. I am a tired man this week.
I hear
Yeah.
you. I hear you.
Yeah. And there's like one more big important thing that has to happen today, which is the launch of the Falcon Heavy.
Yeah. So what time did I know it got scrubbed last night? What time did they
Yeah,
set that for?
I
Like
don't
6:30
I don't
Mountain.
know. Let me see what my launch calendar says. Like I'm just like
Four
I'm just
thirty.
tackling these things one at a time as they come at me. I don't even have time to think too far tactically. We did a video yesterday. We just dropped everything and did a video. So, which I think you just showed.
Mm-hmm.
But
Yeah.
I wasn't around for it. So I'm seeing 3:35 today p.m. Pacific time. So it could go off, well,
4:30.
depending on how long so literally as we end this conversation, that'll happen. So I'll probably go and jump into Everyday Astronauts live stream and yak in the chat with them. So
Yeah. Yeah. Someone just said, what's the Falcon Heavy? Fraser,
what,
what's the Falcon Heavy?
what's the Falcon Heavy? The Falcon Heavy is 3 Falcon 9s Voltron together. And all 3 boosters are reusable. So they'll all, in theory, land. And so like 75% of the rocket is reusable, which is so much cooler than merely using the first stage booster of the Falcon 9. And this is the first launch, of course, is the one that sent Starman off beyond the orbit of Mars. Turns out he's going to come back in 2047 to share his wisdom.
Oh,
I don't know if you've heard
really?
this.
No, I
Yeah.
didn't know that.
Yeah. And then and so the first one was just like really just a vanity launch by Elon Musk launching his car into space. But this one is the first paying customer, Arabsat. It's a 6,000 kilogram communication satellite that's going to be sent to a geosynchronous transfer orbit. And then it's going to communicate, I'm assuming, some kind of fascinating satellite television to a portion of the world.
Yeah. So it's not a dummy payload.
No, this is the real deal.
It's the real deal.
And the cool thing about this is that has 3 Block 5 boosters on it. And the Block 5 is the new booster that SpaceX has been using, the fully reusable one, the one with the titanium grid fins. Every part of it is designed to be reused with minimum maintenance. And so they're learning a ton of lessons about really just bolting these things together.
Yep.
Yeah. And it is it's a incredible engineering challenge to have a rocket with 27 boosters, 27 engines on it, and they all work together in tandem, right? This was why the Soviets failed to be able to get to the moon with their N1 rocket, was they were trying to go down this pathway to use a bajillion separate boosters and try and keep them all coordinated, and they weren't able to pull it off, while SpaceX is able to do it thanks to computers.
Yeah. So I'm going to ask you a question that maybe someone in chat might have, but they're not going to ask. So I'm going to act like I don't know. What does the heavy mean when we say Falcon Heavy?
Well, the heavy is just like the heavy lift capacity. So a normal Falcon rocket can carry around 6,000 kilograms into a geosynchronous transfer orbit, and the Falcon Heavy can take much, much more.
Okay.
I don't know the exact number. I'm sure someone in the chat knows the number, the various payload stats.
Yeah,
right.
they could go
So
to
when you think about
University
these
of Google.
rockets, right? So the Falcon 9, you can have you can go to a low Earth orbit, right? You can
Mhm.
deliver a satellite into low Earth orbit, or you can deliver a satellite into geosynchronous orbit, which is much higher. The geosynchronous orbit takes more energy. And a Falcon 9 can be used in either a reusable mode where that first stage booster comes back to the Earth, or in a disposable, expendable mode where the whole thing crashes into the ocean because you're instead of saving some fuel to get back to the landing site, you just burn it all. And so that lets you go farther with, take a higher payload to a farther orbit.
Gotcha.
The uses 3 boosters. And so it either expands the capability of what you can do in either a completely reusable mode. I mean, a Falcon Heavy, I think you can buy a flight on a Falcon Heavy now for $90 million, which is absurd. Like, while a Falcon 9 is, I think, 60 million. And the prices come down if you want to use a reused one. And so this is right now, the Falcon Heavy is essentially the most powerful rocket that is usable by, for whatever missions you want to do. There's nothing else really on the market. Like the Delta IV Heavy, the one that launched the Parker Solar Probe, is pretty close. Falcon Heavy is next level. And so that's why NASA announced last week, 2 weeks ago, when they're talking about going back to the moon 2024. I think we talked about this quite a bit last time.
Yeah.
That this could be the rocket that would do it. This rocket has in it the ability to take, with potentially some clever docking and orbital rendezvous, this is the rocket that could theoretically carry humans back to the moon. Now, it's not human rated by NASA standards, so safety is going to be an issue that people are going to have to seriously consider. But it's a really exciting thing. And when you think about the fact that Elon Musk and SpaceX developed this without a customer in mind, they just developed it on their own, as their own expense, to develop this, knowing that the market would show up for them, just shows again how smart those people are and how well they position themselves. And now when you look at the work that's going on with the Starship and the Star Hopper, which hopped last week for this much,
right?
Like it hopped, it was tethered down, hopped, and then came back down to the ground. But it tested out a brand new kind of rocket engine, right? The Raptor engines are next level, methane powered closed cycle engines. They exist in a sort of under pressures and temperatures that nobody's been able to achieve before, and you're seeing this starting to move towards reality. We could see, and I think we've mentioned this now many times, right? The SpaceX Starship could just go to the moon, land, people could get out, jump around, get back on, fly back. So it is space, like the Falcon Heavy, if it launches again today and does well, they're already developing the replacement for the Falcon Heavy, which is the most powerful rocket that's out there right now. I mean, SpaceX is running away with the space launch market at this point. The only reasons that you don't want to give all of your money to SpaceX at this point is just because you don't want them to have a monopoly.
Right. Let's not don't let SpaceX become Comcast, guys.
Yeah. Let's give $500 million or $400 million to United Launch Alliance to launch a payload, because otherwise we would just be giving all of our money to SpaceX.
Right. Exactly.
Which is not a really long-term sort of justifiable reason.
Yeah.
But someone's mentioning what Jeff Bezos' company is doing. That's Blue Origin, and that is the viable, serious competitor to what SpaceX is doing with their upcoming rocket, the New Glenn. So stay tuned. It's going to get very exciting. We're going to have serious competition. I'm, really excited.
So are you live streaming the launch?
I'm not. But I think Tim Dodd, Everyday Astronaut, is. He's out there at the Cape right now. He was there yesterday and did his live stream. He's going to do another live stream today. And I like to just jump into his chat and just answer people's questions.
Yeah, we have Das Valdez. We'll probably hop in. I think he's there, so we'll probably hop into his stuff.
Yeah.
He's amazing.
I don't know. Are you allowed to do that? Are you allowed to
with permission
to host?
So
A YouTuber's live stream?
oh yeah, you could. I mean, we watched you with what was that? The lunar eclipse.
Oh, right, with the lunar eclipse. Yeah, yeah,
Yeah. So as long as I have permission, like to,
yeah,
especially with a live stream, like obviously a lot of this stuff on here.
yeah.
Yeah.
Oh, there you go. Susie's saying that CosmoQuest is also going to live stream it. So,
Oh, awesome.
so that's cool too.
Yeah, I know
Yeah.
that Doss is on location though.
Oh, that's amazing.
He does it. That's what he does.
Yeah,
This is like his deal.
that's
So,
perfect.
yeah, he'll go into all the stuff. So there was someone that said something that I think the future involves, it might be kind of segueing a little bit. I think the future involves attaching a chain to Earth, and the other end will be put into a black hole in order to pull Earth away from it going towards the sun, and then detaching the chain from Earth once we're at a desired distance. And he said, silly question, I know.
Um, let me think of an analogy. It's
So
like
first,
it's like giving a piece of string to an angry tiger. I can't come up with an analogy.
just put a
But
chain in a black hole.
yeah,
Can we
yeah. So
start
like the
there
first thing you
first?
do is it's like doing your laundry with a nuclear weapon.
Uh-huh.
Yeah.
Uh-huh.
It gets it clean. Oh, does it right to an atomic level. Yeah.
Just no. Yeah, so we can't put a chain in a black hole.
Yeah.
What's the problem with putting anything into a black hole? What?
Well, I mean, obviously, I mean, the thing with putting anything into a black hole is it goes away.
Right.
It never comes back.
It's
So,
gone.
yeah, that's the problem. Is there is no chain that would be possible. The tidal forces around a black hole would tear apart your chain at an atomic level and gobble up all of the pieces and enjoy them.
Mm-hmm.
So,
Yeah, if you guys want to take,
yeah.
everybody was saying they wanted to take their student loans and put it into a black hole, and I think that's, you
Sure.
know,
Yeah, absolutely. It
sure.
would work like a charm.
Yeah.
Yeah.
Mm-hmm.
Yeah.
Astronomy
I mean,
cast guy, yes.
yeah. Yeah, you can feed a black hole energy, matter, antimatter, whatever you want. People always ask, like, where does it go, right?
Right.
Yeah, it just turns into more black hole. It
Mm-hmm.
goes, where is it? It's right there.
Yeah.
It's still there,
still there.
just smushed.
Can I feed it
Yeah.
hate? If that's quantifiable.
Yeah, yeah.
um,
So it doesn't go. The point is, it doesn't go anywhere. So
right.
we always talk about this idea. People always wonder, like, what's on the other side of a wood chipper?
Mm-hmm.
Don't find out.
Yeah, you don't want to test that.
No.
This is not a vacation place. Just so everybody knows, it's not like
it
you
is
can go
not.
there.
A wood chipper is not a tunnel
No.
to another universe.
No.
No.
I mean, a different state of existence, maybe, but for humans, right? Wood chipper, that's where my brain went. That's pretty dark. But, you know, I've been watching a lot of horror movies late at night, so forgive me.
Yeah. And the sort of the sort of like the thing that I like to sort of the Godonkin experiment that I offer to people is, like, imagine you're standing on the ground, right? And you're being pulled by the gravity of the earth. And then you climb up to the top of a building and you jump off.
Mm-hmm.
And then you experience what it feels like to fall into the earth. Where do you go? You go to the hospital.
Right.
Because you fell into the earth, right?
Yeah.
And so now imagine you fall from, say, 100 kilometers into the earth. You wonder, where does the earth go? I want to know. And so you jump down, you jump off, and you fall down. And of course, now you don't go anywhere, right? You don't even get to go to the hospital. You go to the morgue.
Right.
Now imagine if you doubled the gravity of the earth. Maybe you tripled, quadrupled, 1,000th the gravity of the earth. You would just fall faster and then go smish, right? Swoosh.
Right.
And so just scale that up until the force of gravity of the earth is so strong that even light just goes, right?
Right.
It's just not even able to escape. And you will just get squished right onto the surface of the earth. And in this case, that's all a black hole is. Black hole is just gravity cranked up all the way to 11.
Yep. And someone said, I
So
mean,
do not hope that it is a portal to anywhere.
right.
It is just you getting added to the black hole.
Yes.
In the bad way.
In a very bad way. And I think that's a lot of the things that get discussed with this is everybody's like, well, what's inside of it? Well, I want to fall into one. You know, what if we do this with a black hole and we put something like it kind of, guys, there's the event horizon, right? We can't see any events that happen after that. At that point, that horizon. So there's a reason for that. And if light...
Yeah, and the event horizon is just like where people who are, say, bungee jumping, where their bungees all snap.
Right.
Everybody else can bungee back up and get back up to the top.
That's the no-go zone. Don't try
the
that.
no-go zone, the never getting back zone, even if you're light.
Right.
I know because it just looks like it's just this black, empty nothingness that it's a tunnel.
Yeah.
But that's only because it's so hungry, it's absorbing all the light.
Right. Someone said, does the inner edge of the accretion disk actually move close to light speed? Or is it slow?
Yeah. So I mentioned this in the video. You guys did watch the video, right?
I might make people watch it again. They might have to watch it again. And I'll just, I'm just going to nod.
So one of the big questions that I had as soon as I saw this was like, why are we seeing a picture of M87 and not the picture of the supermassive black hole at the heart of the Milky Way?
Right.
And I got a couple of answers. And one of them was that actually the accretion disk, the material is flowing around the accretion disk in the supermassive black hole in the Milky Way so fast that it changes over the course of, say, 20, 30 minutes. Like you would see it visibly change as this material is zipping around at close to the speed of light.
Right.
And so it's a more complicated calculation to actually be able to make to create the image. But the sort of intriguing idea is that maybe we could then get like some kind of animation, like take a bunch of frames and see it going around over and over again, while M87 is 6.5 billion tons. Sorry, 6.5 billion times the mass of the sun.
Right.
2,000 times more massive than the supermassive black hole at the heart of the Milky Way. And so everything just unfolds more slowly. It takes days for material traveling at close to the speed of light to make it all the way around the black hole. So things just unfold in slow motion, and so you can see it better because it's just not so dynamic. Just a wonderful reason why it's so hard, because it's just everything is just going so much faster at the heart of the Milky Way that at a mere 4.1 million times the mass of the sun, things go too quickly.
Right. Wow, there's good questions coming in. So I have paused chat just so people don't feel like I'm skipping over them. Someone said,
so we're talking about black holes now, are we? Like, we've given up. Can we first just like pour one out for Beresheet lander that just crashed into the moon? Yeah.
So what happened there? Because someone came in and was talking about it immediately.
And then we'll go into black holes all the time.
Okay.
Sure. Well, but I just want to say just a huge congratulations and, sorry, a Canadian sorry to my friends who worked at Space IL, who worked on their lunar lander. It was at the end. It was coming in like, what was it? 900 meters a second sideways, 140 meters per second down, and crashed into the lunar surface and left a pretty big crater. So the hope of the first privately built lunar lander are now literally dashed on the surface of the moon,
which is kind of poetically beautiful, though.
No part of that is poetically beautiful.
It's got a crater now.
It is the hearts and dreams of some really hardworking engineers who did after the Google Lunar Prize was canceled and they knew that they couldn't get their $30 million for achieving this. Right. They still kept doing it.
Right.
And smash.
Yeah.
So we don't know why it happened. We don't know anything.
Right.
Right now, all we know is it lithobraked.
Right. And
it lithobroke.
Little broke to did. So
Yeah.
we'll learn more about that, and that's what we do.
Yes. Yeah.
That's what we do.
But I'm sure next week I'll be able to provide a lot more detail about what happened. But just in general, it just really sucks. It sucks because it was just like a small team
Yeah.
privately built this thing. It they sort of made it go. It went into lunar orbit.
Right.
Everything was done on a shoestring, and they live streamed every moment of the attempted landing, and then you just watched with horror as the numbers went in the wrong direction. Anyone who's played Kerbal Space Program has seen this happen, where you're like, these descent rates are too fast,
Right.
these sideways rates are too fast, and there is no Kerbals walking away from this mission.
I guess why I say poetically beautiful is not just that it just leaves a mark on the moon, but that it shows you that we have to have respect for space, right? Space is pretty unforgiving. It takes a lot for us to learn, and there's a lot to learn about it.
Yeah.
So even through our mistakes like this, right, there's more knowledge
just
gained.
remember that it's still hard.
Right. You learn from it. Space is out to kill you.
Yeah.
It doesn't like you. It doesn't like me. It doesn't like you. It doesn't like anything we try to build.
No, and it has come up with a lot of imaginative ways to end us all.
Right. So we learn, and that is unfortunate. I can only imagine the time that went into that.
Yeah. All right, let's go back to black holes.
Yeah. So someone said,
questions.
so what's the next step after we've seen a black hole for the first time? Where does this lead us? And I think that's a great question, by the way.
Yeah. So I mean, this is just like the image that was released today is the latest image that's been taken by this collaboration, the Event Horizon Telescope, and they've actually been taking similar imagery every year and building up with adding more and more telescopes, developing their techniques, refining their algorithms, and releasing better and better images. This was the big one. This was the one where they pulled out all the stops and set up all these telescopes all at the same time to capture this image. And so with the clarity and resolution that they got with this, you're going to see images like this show up every couple, I'm sure once a year, as they continue to, get the band back together, take an image of the black hole, add more data to what they're looking at. The M87 and SAG A-star are the best candidates because they're essentially in the sky. They are visually the biggest black holes that we can see.
Right.
SAG A is close, relatively close, 26,000 light years away.
Light years, yeah, that's pretty close.
Yeah. And M87 is big, and so
it's
and
big, but it's super far.
Yeah, and they happen to be big in the and big is I'm sure you've heard this thought that this is about the size of a moon, of a orange on the moon.
Mm-hmm. Yeah, we were making jokes about that.
The size of this object that we're looking at. Mm-hmm. So you're going to see them try to push the limits of this technique. Are there other black holes which are maybe smaller but closer, bigger but farther? Can you, with what they got out of this one, could they show one that's maybe half the size or a quarter the size visually? Right. And so I think that with how well this worked, they're going to explore as many different targets as they can do, and then crunch the data on those. So we're still waiting for the SAG A, which should be the good one.
Yeah.
Right. This is the appetizer, and I think Sagittarius A is going to be the big one.
Yeah.
The one that's going to get really exciting.
Yeah, because people identify with it more, right? That's our supermassive black hole.
Yeah. Yeah. Exactly.
That's ours.
Yeah. Isn't that
we
weird?
Own it.
Yeah, I know.
Even though it totally own us.
Share a kinship with which we just talked about, a horrible monster killing machine, but it's ours.
Yes.
Right. It's on our team.
It's on our side.
Yeah.
Just joking. So someone asked what happens, if there's another black hole. And so I think this is kind of leading into the black hole merger stuff. I'm thinking. I scrolled down, but I saw someone else replying to it. Like, what would happen if another black hole collided with this black hole? What would happen?
Right. So, I mean, in going into this, if you look at the actual original paper, they had a whole bunch of simulated situations, and then for different kinds of scenarios. And one of the simulations that they made is if this was actually two black holes orbiting each other in the process of merging. And so there's a way that should look. And they didn't see that. If you look, like, this is precisely what one of the simulated environments that they were expecting to see.
Yeah.
So how do you get a black hole with 6 billion times the mass of the sun? Well, it ate a bunch of other black holes over the history of the universe. And so we know that so what happens, right? If two galaxies like the Milky Way and Andromeda collide with each other, their black holes are inevitably drawn to each other and start to orbit one another and get closer and closer together. And then they merge into one more massive black hole. So when Andromeda's black hole, I think, is like 100 million times the mass of the sun, while the Milky Way's one is 4 times the mass of the sun, million times the mass of the sun. So you'll end up with a black hole that is 104 million times the mass of the sun. But the other possibility is, if the sizes are dramatically different, you can get a situation where one black hole will just literally be bounced out into an escape velocity.
Yep.
And so you can have a rogue supermassive black hole that is just careening through the universe, invisibly wrecking things as it goes.
Do we know of any galaxies which evicted their black hole?
Sorry, do we know of any galaxies of what?
That evicted their black hole?
Yeah, you can see there's I don't know the exact names of them, but you can actually see black holes that are in these escape trajectories. And so the thought is that they bounced out, because it's really weird that you would have two black holes and yet one could be kicked out. Like, you can imagine a 3-body interaction where there's 3 black holes all coming together at the same time, and the weird gravity between them kicks one out. But it now really looks like you can have a situation where two will just go two. One is so big and so massive that it just kicks the other one away.
Yep. Didn't pay the rent.
Ricochets instead of going in.
And so there's oh God, there's so many questions. Some of these I can answer after. Joe, I'm not sure about, even just because that one is close. The V616 Monocerotis, the one that's, what is that, 3,300 light years away. So again, these were chosen specifically due to, again, this one's sheer size. M87, and it's far away, like 53 or 50. I've heard 53 to 54 million light years away.
Yeah, 54 million light years away.
Yeah. So yeah.
It's 2,000 times bigger and 2,000 times farther.
Yeah. So
it's kind of like seeing the sun and the moon in the sky, right?
Right.
The sun is, I forget what the number is, 80 times bigger. I forget the number. Anyway, the sun is bigger and farther. But it works out so that the sun and the moon are essentially the same size in the sky.
Yeah.
But the sun is actually bigger. 400. There's the number. Yeah. So the sun is 400 times bigger than the moon and 400 times farther than the moon, and so that's why they look the same size in the sky. In this case, same thing with these two black holes.
Someone says, how come the data taken to produce this image is absolutely massive?
Right. So what happens? So they use a technique called interferometry, where you merge the capabilities of all of these telescopes, and by positioning them across the entire planet, they act like one big telescope. But the trick is, to be able to do this, is you have to line up the wavelengths down to the exact wave.
Right.
So they're gathering this at a 1.3 millimeter wavelength, and just for comparison, right, visible light that you can see with your own eyeballs is, say, 600 nanometers, 400 nanometers.
Yep.
Very small, right? And so if you imagine in 1 second, you're going to have a lot of billions of wavelengths that have gone by you, right?
Mm-hmm.
While when they're 1.3 millimeters, you're going to have less wavelengths. And so the magic of gathering images in the radio spectrum is that you can line up your wavelengths after the fact, as long as you have a really good clock. And so that's what they use. Every one of the observatories used, oh, there you go. That's cool.
Yeah, no,
Every
I'm
one
this
of
is
the,
radio.
yeah, every one of the observatories had an atomic clock, and they essentially all started their watches at the exact same time in April 2017, and then gathered data for a week. Every time they could see these objects in the sky, they recorded as much as they could with incredibly detailed timings. And then they took all of this data on all these hard drives, brought it back to their various supercomputers, and then had their algorithms line up all of the wavelengths to the exact same wavelength. And again, that is the key, because that's when you get that's when it turns into a telescope the size of the planet.
Yep.
Right. People always ask you, like, could you, why couldn't we all just contribute some telescope time to build a telescope the size of the planet? And all you do, like, if you have a telescope that's a meter across and I have a telescope that's a meter across, and we both turn our telescopes at the same object and record some data,
right,
and then we share our images, all we're getting is the equivalent of a telescope that's 2 meters, that is 2 square meters.
Right.
But if you and I can align our telescopes so that they are synchronized at the wavelength, then we get a telescope that is as big as Vancouver Island and wherever in Colorado you are.
Right.
That is this big telescope. It has a resolution that is incredibly precise. So it's an amazing trick. Now, you don't get the same. You still need a big aperture if you want to gather like very faint objects. But if you want to resolve things like where's the black hole and where's the accretion disk, these kinds of interferometry is the perfect machine for that.
Yeah, exactly. So yeah, and so they took the radio frequencies, right? And they applied that to what we see visually, right?
Yeah.
To what our meat cameras can see.
Yeah.
So that's where you see those brighter regions, and which would infer that there's hotter temperatures there.
Yeah. So I mean, like, radio telescopes work differently than a visual.
Very differently.
Does.
They're not as pretty.
Yeah. Well, except I think this is fairly pretty.
I do too, but we're nerds.
But like when you build a visual telescope, you're taking a picture, and it's very similar to what your eyeballs see. The way a radio telescope works is you're pointing your radio telescope at a spot in the sky, and you're measuring the amount of radio waves that are there.
Right.
And then you move your telescope a little to the side, and then you measure how much radio is there, and then you move a little more. And so you're kind of like building up this map of the sky pixel by pixel as you go. And so you have to like build up these images, and now modern radio telescopes have more resolution. They might have, say, 4 pixels they can do, or 16 pixels at the same time. But in general, they don't gather an image the way a visual telescope does. And so it's a much more laborious process to build up an image in the radio.
Yeah, and this took like 2 years?
Well, the actual data took a week.
Right. But so the actual photograph itself, not right? Wasn't it like a 2-year or like not the photograph, but the collaboration, getting everything synced up?
The follow on, they took this data in April 2017, and it then took it took 2 years. It took them a year to do the sort of the first version. So what happened was, sorry, my phone is trying to tell me about the Falcon Heavy launch.
Stop it, phone.
Stop it, phone. I know it's going to launch. I'll bet you it'll scrub. I have no scientific reason, but this is a first launch, new cores. They want to be really, really careful. If there's anything that causes a problem, they'll scrub, because they don't want to, this is important. They need to be successful, especially now. So
yeah,
I have no reason to know, but I just feel in my bones there'll be a few more scrubs. Yeah, we got a scrub yesterday, and like they had high winds.
Yeah. Someone said, why are you guys saying that radio telescope is electrowave, not just radio? What?
Radio is just on the electromagnetic spectrum. I wish we had some kind of visual aid that could show
Look, you
us
have, I know. I wish
how
you,
radio is on the electromagnetic spectrum,
it's
just
down
like
here.
visible light. Yeah,
It's
it's
down
over there.
here.
But it's all the same thing. It's all just photons.
These are all
So,
photons.
Yeah.
Wonderful
and it's all the same
photons.
thing. And so you just need to show a different part of the spectrum. And so different telescopes, X-ray telescopes, gamma ray telescopes, infrared, ultraviolet,
Yeah.
microwave, they're all just seeing different photons excited to different levels.
Yeah, we have the Chandra X-ray telescope that really we look at a lot of black holes, things like that with specifically that wavelength.
Yeah,
that
and
portion
it's a totally
of the
different
wavelength.
like seeing X-rays is a completely different technique from seeing radio waves, and a different technique for seeing, like you can't wrangle X-rays. They don't let you focus them the way you focus a regular telescope. You can't just build a mirror that collects X-ray photons. You have to slightly change their angle. You have to politely ask them to funnel down onto your imaging system.
Right.
So it's a totally different machine. And yet you're just seeing the same thing. It's just a photon, right? If you fly close to the speed of light towards radio waves, they'll move into the visual. You could see them with your eyes if you were traveling towards them really quickly. And if you traveled fast in the opposite direction, away from, I don't know, something that's visible, you can start to hear it on your radio. So it's super weird.
Yeah. And we just went over that question. I'm sorry, I'm just trying to see. And Paul, yeah, that was pretty cool. He had a question way above here talking about maybe could other elements appear maybe on our periodic table. I feel like I'm failing at asking the question.
No, I understand the question.
Okay.
I mean, the question is like will we find more stuff on the periodic table beyond the elements that we know of?
Yes.
Is there some stable elements that we're going to find? Something that's going to, for example, allow you to float, and we'll call it unobtainium.
Ooh, I like it.
And the answer is almost certainly not. And the reason is just because there are incredibly powerful particle colliders out there in the universe known as supernovae, that when a gigantic star with 50 times the mass of our sun dies, it turns to iron in the middle of the star. All the outer layers come crashing in at 70% the speed of light, and all of the heavier elements that we see in the universe come from those moments.
Right.
And gold and platinum and iridium and uranium, all these things are formed in probably supernova, core collapse supernova, or colliding neutron stars. The point is the universe has built particle colliders far bigger than anything we can ever build, and yet we see the mix of elements here on Earth of what are the results. And so if something could be stable, then we would find them, because we can't compare to what two colliding neutron stars can do. But the amazing thing to think about is that yes, these things form, right? That as a supernova is, or as a black hole, as a supermassive star is core collapsing and is forming a black hole and is turning into a supernova. In these moments, super heavy elements are being formed. It is squishing protons together into exotic elements, but they are all decaying right away.
Right.
And so we'll never get a chance to see them.
Yeah.
And so every time that we collide things in our particle accelerators, we're glimpsing just a hint of what those conditions must be like and what weird elements must be getting formed. But they're all just falling apart. They can't hold.
Sketchy asks, did this, and this is a great question, Sketchy. I want to say over and over again, from what I've read on the internet, maybe you too as well, Fraser, people are confused why this is so important. When I said Einstein is right,
Yeah, I saw a clip on Reddit.
Oh, yeah, and saying that people are like, yeah, well,
What? Einstein
what?
is right. What? I believe that's what you said.
Right. And from what we know, again, is that he didn't necessarily predict black holes' existence and advocate for that.
No, he didn't like him.
No. Mm-mm.
No, no, he was against it.
Yeah.
So it's hilarious, right? In
Hmm.
that um, Mother Nature confirmed Einstein's theories about relativity, even though he didn't like the idea of black holes. That
Specifically, which relativity are we talking?
general relativity. So
Yeah.
the the math that underlines the existence of the black hole and the way things work around them and the speed that the accretion disk is going around and the shape of the event horizon, these are all calculations that can only be done with general relativity.
Right.
And yet it is not a thing that Einstein really liked the idea of infinity, of relativity sort of leading to infinity in the way that they do.
Yeah.
And so he was not for it. And yet, after his death, I think it was like 10 years after his death, someone proposed, even came up with the name of black hole. So it was outside of his expectation that these, and no one even could think of a process that
Right.
would create them in the first place.
Yeah.
And then they realized that supernovae were new stars turning into black holes, dead stars turning into black holes, and they started to realize there could be a mechanism for
Right.
this.
Yeah.
But when you look at this picture and you look at the original simulations for how they were going to get to this picture, you can see, they just had to crunch Einstein's calculations to get all the features and structures that they should see, and
Right.
then the result matched their predictions. So
Yeah.
Einstein was right.
I-
But
do you want to say Einstein? Because I mean, apparently people don't know how German works, but
I'm Canadian, so I'll ruin all.
I go in between. I try to do
Yeah,
halvesies on that, but
there
yeah.
you go. Yeah. Well,
Um,
like as a Canadian, right? Globular clusters, lava.
lava
That's the one that
tubes.
people think is
I
hilarious
love
the way I
that
see it.
one. I love it when you
Yeah.
say lava tubes. We're just gonna have to
Lava.
find a
Lava
lava tube,
tubes.
right?
Lava tubes. Yeah, I had someone like yell at me, like, it's lava.
It's lava.
Yeah.
Get it
Oh,
right,
okay.
huh?
Sorry.
Yeah. So, but that's the cool thing. A lot of people, I think, don't know that Einstein didn't think that these were a thing. That he didn't go around giving lectures on black holes or saying yes, these have to exist. I think that's
Right.
a common misconception. So when people say that he was right, we are referring to, and I speak we as in me. So that's very actually. I'm going to say I'm referring to exactly what Fraser said. In terms of GR, which is general relativity, not special relativity, but general, which includes gravity.
Yeah. And
That's
obviously,
cool.
the specific is way beyond my pay grade. So,
Right.
but
I'm
I
not
highly
making enough
recommend, if
money.
you go to the European Southern Observatory's press release, they link to the 6 papers that were published as part of the announcement, and they're surprisingly readable. Like at a certain point, no matter, like, unless you're actually can do the the general relativity math, your
Right.
eyes will glaze over. But you'll get to a certain point where you're like, this is really cool.
Right.
Yeah, I understand. And you can see all of the different pictures and all the different simulations and all their expectations, and then they're mapping out what actually happened. So yeah, it's amazing to sort of see the underlying scientific work that went into it.
And I might be stepping out of my realm of saying I kind of know this because I knew a little bit more about the black hole stuff, but didn't he kind of say the same things along the lines with gravitational waves?
I don't know about that.
Because I think he kind of
No,
thought
I mean,
maybe they could be a
he
thing, but we're
was
not sure.
no,
Like he
he was
didn't.
the thing that he didn't like was the idea of the universe expanding originally.
Oh yeah. I
And
remember
so
that.
he came up with the cosmological constant to figure out how you could have a steady state universe.
Right, which that was a joke. Constant haha.
Yeah, and then when they realized the universe was expanding, then that made it that he didn't have to worry. They didn't have to worry about the weirdness and have to put in that constant.
Right. Right. Um, and so where someone asks, where will we be in 3 years' time in terms of taking pictures of black holes? Is this something they're going to keep doing even after?
Yeah, I think so. Yeah. You're going to see these. I mean, all these telescopes have other jobs, right? They for the rest of the year, the telescope, the South Pole Telescope and the ALMA, they all have a ton of science work to do. But I think they're going to get together and have a party once a year and take a picture. And then they'll go back to doing their regular jobs, and then they'll ship all the hard drives back and keep updating. So this is just the beginning. You're going to see better and better and better images.
What
and
a
I think
time to be alive.
Yeah, and just like you mentioned gravitational waves, and so think about how you could have this moment where you could have gravitational wave telescopes detecting a black hole merger and then them gather imagery of this situation coming together, or of the aftermath of it, using something like the Event Horizon Telescope. So it's just another amazing kind of astronomy that is now suddenly possible. And you watched this one. You didn't watch the other episode that I did, right? You did
Not yet.
The one about
Not yet.
So
I have to still nod to that one and say he's right.
Yeah, that's the one that we released on Monday. On Tuesday, as opposed to the one that we did on Wednesday. Yeah, yesterday was busy. That there are these telescopes. There is the 30-meter telescope, the extremely large telescope, and the Giant Magellan Telescope. The Giant Magellan Telescope's first, 2024. It is mind-bending how much more powerful these telescopes are going to be than the best telescopes that exist right now. So we are now 5 years away from another revolution in astronomy.
Yes, absolutely.
Not to mention 2021, when the Large Synoptic Survey Telescope shows up.
Let's see. There was another good question. Oh, wait. Speaking of telescopes and parties and things, where people get together, hopefully a lot sooner than, an annual type deal. So are you thinking maybe we can do a virtual star party here soon? Because I would really love for you to be a part of that rather than me doing it on my own just yet. Because Fraser.
Were you have you got control of the telescope? Were you going to do one?
I've done a little bit of training, but there was really, really bad stars. But Fraser is love. Fraser is life. It's amazing to have you on here when we do that. So, and also we can make all the jokes because Fraser's going to keep us on our toes, guys. He'll keep us going.
I feel
because we have the new moon, but it's not a new moon anymore.
Yeah, it's not a new moon anymore.
Not
but
anymore.
I think I want to do that. I want to because I'm such a morning person. I really have to force myself to just go what? For the next month, I'm going to run the telescope every night, and I'm just going to force myself to do that, and then shift my whole schedule around, because I want to get better with that telescope, and there's so much stuff that I want to show off, but it's just such it is an ordeal. It's hard on me. So
sorry, I'm telling people, I can just say it. Let us get a solid understanding of the standard model first, Tamer. Well, there's a lot of problems that people will say with getting a unified theory, a theory of everything. So
it's in progress.
That's a work in progress. WIP, by the way. That's a loaded question. So one thing, guys, that I'm talking about here with Fraser is we usually do these virtual star parties. Not usually. Every now and again. We haven't done them.
Done every now and then, yeah. We have occasionally done these star parties.
Yes, thanks to OPT, which is Oceanside Photo and Telescope. And they allow us to use these remote observatories where we can go and look at the night sky and live stream it. So we take pictures of deep sky objects. And we haven't done that in a while because we had really crappy weather for the first 2 months of this year.
Yeah, it was a really weird weather for California for the last. Anyone who's in California can definitely confirm weather was weird for the last couple of months.
So usually those are better times for us because night is longer, the sun sets, we can do these things. That's why Fraser's talking about that now that we're in this daylight time where sun's going to be up more and more as we get through the year.
It's worse and worse and harder and harder.
We like nighttime, guys. Are you
Yeah.
shocked? So we'll have to plan that here soon. I know that there's a lot of my month is kind of weird, but
Yeah.
we'll
So,
talk
but
about
my
that.
commitment is as much as possible. So
Yes.
feel free to remind me of my commitment to operate the telescope and share the night sky.
Yeah, and you'll see that I won't remind you around a full moon. We are going to dodge that
No, we learned a
like the
terrible
plague.
lesson.
Yes.
Yeah. Although Dustin and team just got back from observing in New York in Times Square with a bunch
That's
of
right. They
telescopes.
did. Yeah. I saw
Yeah,
that.
and so they were posting a bunch of stuff about how they were able to set up right in the middle of Times Square, in the middle of the worst light pollution you can imagine, and took pictures of cool deep sky objects thanks to their narrowband filters. So one of the telescopes, the one in Texas, is equipped with a narrowband filter, but we could probably nag them to put that on the California one as well. But so it's just a matter of like everybody's so busy. Someone needs to put in the time and make it all go. And
Yeah,
make it fun.
and the sky needs to
Yeah.
cooperate because it was not cooperating with me.
The sky was cooperating. I mean, there
Here
was
even.
times when a person could have like made it work and
Probably.
watched for openings and sucker holes and operated. And there's 2 telescopes, right? Like it's just a matter of, it's just like you. Game of Thrones is on, right? And you're just like, oh man, it's Sunday night. Do I want to run the telescope or do I want to watch Game of Thrones? And,
I'm excited for Game of Thrones.
Popcorn with my wife and have a beer and go to sleep.
Yeah.
So
no, that's different.
That's the problem.
Yeah,
I think I will squarely place that as the problem.
Yeah, no, people here on Twitch are more excited probably about like, well, Fortnite or
Yeah, I gotta watch Ninja.
RP. Right. So what's the website for the telescope? Okay, so how the observatories
right here
work
on Skylius's channel.
Yeah, or on Fraser's. Sometimes
or on mine.
We'll put it there, because both channels definitely
need
love.
Channel.
Yeah.
But it has to be good if it's going to go on my YouTube channel. Like I gotta raise the
higher standard
quality. Yeah, they gotta raise the standards because YouTube's algorithms are punishing. So if you if you create bad content, then YouTube thinks that you're just a stinker overall and won't send you traffic.
Yeah, someone said so. The Israeli probe crashed.
Wah, wah.
Yeah, we were talking about that earlier. So, but yeah. So we do those. But we'll get one done here soon. It's just it's a lot of effort for us to kind of get together and do that. But don't worry. So it's a remote location that we can access. We have 2 different places right now, and that's pretty amazing to have 2. To have one.
You know what part of it is like
cool.
it feels to me like it's terrible.
Go on.
And like it would be like doing a concert or like sitting around like playing the guitar and being awful and wondering like why people want to watch you do this.
I feel like
and
that's like Bob Dylan just wrapped up.
It's great. But for me, it's just like, oh, this is just not great.
No,
So,
but for Twitch, I mean, again, when people understand the technology that we're utilizing, it is crazy. We are able to move a telescope in another location,
in real time, and share pictures with people.
Right, and show people of galaxies that are millions of light years away.
Yeah.
I mean, that's pretty cool.
I know. It's magical.
It is.
Still is just like, for me, I'm just like cringing.
Some people still like Bob Dylan, okay? So, but yeah, we'll plan one of those, and guys, and we'll tweet it out when that's a thing. But again, that's but you have an opportunity too to go to. We still have places open for the All Stars party.
Yeah, I mean, if you want to just hang out with us,
if you want to just hang out with
telescopes,
and have a beer,
and
talk about star stuff.
Join us in Joshua Tree.
Yeah, and there's a command for that. It's All Stars. We did add that one back in because there it is right there. So you can go there and look at that. If you want to hang out with really cool people, and I'm not talking about me because subpar. Hey, I'm not too far from Joshua Tree. Yeah, so there you go. They even dropped the price on it too.
Yeah.
So, and it includes a lot of things.
Food, accommodation in a luxury resort.
Yep.
Us. telescopes, side trips.
Yeah. Yeah, and then we will probably have we talked about this last week, but you guys aren't disagreeing too much anymore, so I don't know. It might be scrubbed. We might just have a conversation about it, the whole Fermi paradox thing. It might just need to be a conversation rather than a debate, because it does sound like there's not much
Yeah,
of a
Paul and I
debate
don't
anymore.
disagree. I mean, did you bring this up with him that we kind of don't that the amount that we disagree about is getting smaller and smaller?
No, but I could see that, because it
Yeah.
kind of happened with me too. Although I'm not going to admit that publicly yet. Just
Really?
joking.
You're not ready to come out of the closet?
No, not yet.
Okay.
I'm working on it.
All right.
Okay. Okay.
Yeah,
You know, I've got
well,
till end of June. Okay.
just like, at some point you'll realize the existential horror of that we are probably alone in the universe will finally just sort of sink in, and you'll be one of us.
Oh God! Debate the existence of the mantis. That's right. You guys. I did share. Well, Lottie, I did share the image that you made of the copy pasta that came
What?
from. Remember,
People made a picture of it?
No, well, Lottie, I shared it with you in Discord. I showed you the copy pasta from that Q&A that you had, where the guy was saying, "Yeah, destroy the moon is intelligent decision."
Oh my God, you did.
Yeah, that's what that was. You can create mountains, seas. The sun moves towards the center of the galaxy. Is a tornado. The monster of the pyramid will want to steal this DVD, then cultivate more. Number one, will
this
leave.
is a beautiful thing.
Yeah, see, now you're getting it. I'll keep reading.
I didn't realize what that was.
This is what you do when you meme. This is top-notch memes. Number one will leave. Here, I'll bring it up here on my stream too while I read this, because a lot of people are like,
you guys are
"What's
beautiful."
happening?" Yeah, that's Wolati.
I'm tearing up.
I know. Isn't that amazing?
Oh.
Yeah, you're not doing it right unless you know how to meme right. So, yeah, this is
What's
it.
the fact that people would set aside some time to make something so weird into a form that we can look at?
Yeah. So no, this all makes sense now. So let's see. The monster of the pyramid will want to steal this DVD, cultivate more. Number one will leave the mantis to have won. So look, the mantis has won right here. And is it possible to destroy with tunnel grinder? And then we have Rubby Canyon by waves, earthquakes with magic. No, is opposite trap. Sure, the monsters insert your body after don't remember.
Oh God, that is beautiful.
That's it. That's that. Yeah. Yep. So, but who gets the spice? Right. These are the real questions, but.
Oh man, I've got to tweet that if I'm allowed.
Oh, you're totally allowed.
All right.
Oh yeah, that's Wolati.
I'm not sure. This feels like just like a real violation of Article 13.
Yeah, no.
I mean Article 17. Just like
no.
Like the European Commission is coming after me just from moment one.
We might have to replay that Q&A just for that again, because we saved that. That is an actual thing with the copy pasta.
Perfect.
Oh no, we don't have a clip yet. I was surprised nobody took a clip of it, but with magic is opposite. No. So yeah, and I even tweeted it out with the photo saying, welcome to my life in space, because we get a lot of people that will come in here and say things that are just as fragmented, where I'm sitting here going,
yeah. But is it too many words? Like it won't fit within a tweet, I guess.
No, you might have to do the tweet longer.
Yeah, or like embed it into the picture.
Yes.
I think that's what I'll do. I'll just merge them together so you can see the picture.
Right.
And tweet at the same time. Yeah.
Right. So, I mean, we'll go to that Q&A. We'll watch it again because that was... I remember I actually went and got some water, came back up, and that part was playing, and you were reading the question. And I sat down and heard half of it, and I saw your face. And this is the beautiful part of Fraser, is he's able to maintain all stoicism. Like, he was completely stoic.
Yeah, that is the one. Like, I'm sure we'll release the blooper at some point, but I think I took like 5 or 6 cracks at coming up with a response.
The mantis has won.
Yeah, and then in the end, I think I said just bold claim.
You need evidence.
Do you have any evidence or something like that?
Extraordinary claims require extraordinary evidence. So yes.
That's a bold claim. Can you cite your sources?
Yeah. So when you guys see us watch Q&As from Fraser, it's for those moments. There's a bunch of great content in between those two, but
Yeah.
you know, he's not without dealing with such fun questions. You know, it happens.
No, I think people really enjoy it.
Yeah,
Actually,
I do. I know
throw a
Chet
couple
does.
of them in every question show, just because like there's nothing more fun than just enjoying either the weirdness or just the nastiness.
Oh yeah.
Like you can just count on every week a couple of people just being so outlandishly nasty on my channel that I will have energy for days.
Right.
And obviously it's so weird that a person, like, where are they in their lives that
Yeah.
what they want to do is they want to take some time out of their busy lives to try to make somebody else feel bad.
Mm-hmm.
Like that's fun for them.
Yeah.
Oh, I just feel sad for you.
We had a guy come in yesterday. He created like 3 or 4 accounts just wanting to scream about flat Earth. But I still don't believe he's a flat earther. I'm not buying it.
None
Yeah.
of them do.
I'm not buying it. They
No.
want me to buy it.
No, they're all trolling. Yeah.
I know.
So that's the thing. Like they don't need to get me to believe in flat Earth. They need to get me to believe that they believe in flat Earth. I'm going to need some evidence for that.
Heyo, that's really where it goes. Like, I need to believe that they believe, and if you come in and just troll my
me
channel,
that you believe this.
Yeah, we'll just troll you right back. That's all we'll do here. Is I don't really, I wasn't convinced, even with 3 accounts.
Not convinced. I didn't buy it. You didn't you tried, and I just am not convinced that you believe this.
I'm not sold yet. Do you have a brochure?
I don't want a brochure.
Do you have a suit? Okay.
Yeah.
What if
you make them believe that you believe?
What if? But it is on that 4 o'clock, and I know the Falcon Heavy is a thing.
Yes, I've got to go do my job.
You gotta go. So
yeah.
Yes. So thank you so much.
No problem.
We'll see you
Happy
next
to be
week.
here.
Yeah. And guys,
I've got
Fraser.
Speaking of the newsletter, I'm writing tomorrow's newsletter right now, and by am writing I mean haven't started yet. Mm-hmm. So I will be writing my newsletter. It's going to go out tomorrow morning. universetoday.com/newsletter.
Yep. All that stuff's right here, guys. And we're going to let the end of his video play so you guys also know. I try to leave at least one video going so that you guys know where to find him. But great source for space news, and very lucky and fortunate to have him.